So final question, because I know we've come up on time. There may be some physical limit to how much we can grow in the universe. So to give an example, the philosopher Wilmer Caskell, but also other thinkers like I think Holden Karnofsky have written that if we continue our roughly 2% economic growth rate, within about 10,000 years, we'll be at the point where we have to produce an implausible amount of output per atom that we can reach in order to sustain that growth rate. So if it is true that there is some physical constraint on how much we can continue to grow, should that make us pessimists about the ultimate course of civilization or civilizations in the universe?
So the short answer is no. But it is true that if we continue to grow at 2% per year or whatever it is, then in 10,000 or 100,000 years or whatever it is, we will no longer be able to grow exponentially because we will be occupying a sphere which is growing. And if the outside of the sphere is growing at the speed of light, then the volume of the sphere can only be increasing like the cube of the time and not like the exponential of the time. So that's true. But that assumes all sorts of things, all sorts of ridiculous extrapolations to 10,000 years in the future. So, for example, Feynman said there's plenty of room at the bottom. There's a lot more room. You know, you assume that the number of atoms will be the limiting thing. What if we make computers out of quarks? What if we make new quarks to make computers out of? Okay, the quarks have a certain size. What about energy? Well, as far as we know now, there's no lower limit to how little energy is needed to perform a given computation. We'll have to refrigerate ourselves to go down to that level, but there's no limit. So we can imagine efficiency of computation increasing without limit. Then when we get past quarks, we'll get to the quantum gravity domain, which is many orders of magnitudes smaller than the quark domain. We don't know what that we have no idea how gravitons behave at the quantum gravity level. For all we know, there's an infinite amount of space at the bottom. But you know, we're now talking about 1 million years in the future, 2 million years in the future. Our very theories of cosmology are changing on a timescale of a decade. So it's absurd to extrapolate our existing theories of cosmology 10,000 years into the future to obtain a pessimistic conclusion, which there's no reason to believe takes into account the science that will exist at that time.
Also, I'll add, and this is a theme that David has explored as well, that humans really thrive on information, on knowledge, not just on stuff. So when you talk about growth, it doesn't mean more and more and more stuff. It could mean better and better and better information, more entertaining virtual experiences, more remarkable discoveries or ways of encountering the world that may not actually need more and more energy, but just rearranging pixels and bits in different combinations of which that we know the space of possibilities is unfathomably big, and growth could consist of better for cures for disease based on faster search in the space of possible drugs and many other massive advances that don't actually require more joules of energy or more grams of material, but thrive on information, which is not limited.
It might largely require replacing existing information rather than adding to information. So we may not need exponentially growing amounts of computer memory if we have better and better, more and more efficient ways of using computer memory. In the long run, maybe we will, but that long run is so long that our scientific knowledge of today is not going to be relevant to it.